Hi, I'm going to talk about straight lines in coordinate geometry. Now this means that I'll be looking at a graph with the x and y axis, and I'm going to look at how straight lines are described, how to find the lengths, how to find the equations for the straight line, and how to use these ideas to solve problems using xy coordinates. We'll start by looking at the length of a straight line. Start with the xy axis. And suppose we have 2 points. Okay, and one of them has the coordinates 1, 2. The other one 3, 4. Now, if we now want to find the distance between them, this is how it can be done. I'm drawing this dashed line to show the connection between the points and their xy coordinates. Okay. Now let me draw this triangle. Now first, this is the length that I like to find. Now let me draw a right-angled triangle with a horizontal side and vertical side. Now from the x and y values of these 2 points, we can tell that this distance from 1 to 3 is 2, that distance from 2 to 4 is also 2. And since this is a right-angled triangle, I can find the length. Okay, let me call that C. The length is C. Then C, I can find using the Pylorus Theorem, which says that C squared should be equal to A squared plus B squared, and if that's my A and that's my B, I have 2 squared plus 2 squared. Okay, and then C would be square root of, that would be 4 plus 4 and get square roots of 8. So that's how I find the length of a straight line joining 2 points. Now, and from this idea, we can derive, or we can make a formula that we can use for any point that has any x and y coordinates. Alright, we think of it this way. We think that that number 2, this number here, right, came from subtracting the 3 and the 1. That number came from subtracting the 4 and the 2. So I'm tracing back the number to see where it comes from. So the 2 there went into there, so that's actually the 3 minus 1. And the 2 there came from the 4 minus 2. So this was actually 3 minus 1 squared, and the 2 that actually came from the 4 minus 2 squared. Okay, and to make a formula that I can use for any x and y, what we could do is we could call this 1 here x1. I call the 3 there x2, and the y value here y1, y value there y2. So x1 and x2 would refer to that point, so that's point number 1. x2, y2 refers to that point, so that would be like point 2. Alright, so that means 3 minus 1 is x2 minus x1. And 4 minus 2 is y2 minus y1. Alright, so that is the same as that. So now I can use this formula for any other values of x1, y1 or x2, y2, and I can use it for different cases. And let me just complete the formula. So we need to take the square root before we get the actual length. Before that, it is the length squared. So the length would be the square root of that. Okay, so now we have a formula for the length of a straight line joining 2 points on the xy plane. Okay. Let's have a look at midpoint now. Suppose I have a straight line between 2 points in the xy plane, and I want to find the position of the midpoint. Point in the middle of the line, I want to know what are its x and y values. That's x, that's y. Okay. So now let me draw some lines to help. Okay, those are the vertical lines for the x coordinates, and the horizontal lines would be this. Now the midpoint there divides the line into 2 halves, right? Into 2 equal lengths. And I need to find the x value of that. So I must think about the connection between the 2 equal lengths here and the value of x. So let me draw a horizontal line here to form a triangle, and let me think about this vertical line that goes to the x value. Now if you look at this, you see one triangle there and another triangle there, and those 2 triangles have the same angles. They are parallel sides. So they have the same angles here and here, same angles here and here, and a common angle there. This means that the 2 triangles there are similar triangles. And we know that for similar triangles, the corresponding sides are equal. So this means that if those 2 sides have the same length, So these two sides must also have the same length. So therefore, x must be the midpoint between 1 and 3. And we know how to find x, because x must just be the average of 1 and 3. So x is equal to 1 plus 3 over 2. And likewise, if you think about the y direction, we can imagine the same picture for that side of the drawing. And then we would conclude that y must also be at the center between 1 and 5. So therefore y must also be the average of 1 and 5. So that would be 1 plus 5 over 2. And in this way, we have just found a way to calculate the coordinates, the x and y of the midpoint. Okay, so as with the case for the straight line, let's make a formula that we can use for any 2 points, that we can use to find the midpoint of the line joining any 2 points. So we need to turn the numbers into symbols to make it more general. So let me call that x1, call that x2, and call that y1 and y2. Okay, so x1 and y1 are the coordinates for this point 1, x2, y2 for that point 2. And in this calculation, we see that the 1 here is the x1 and the 3 there is the x2. So I can write this as x1 plus x2 over 2. 1 and 5 are the y1 and y2. y1 plus y2 over 2. So now I have a formula. Alright. Now let me write it in a form that looks more like the xy coordinates. So I would say that the midpoint, right, xy coordinates, we would normally put a bracket around the x and y values with a comma in between. So I would write this up there, and I would write the y value of the midpoint up there. So now we have a formula for the midpoint, and you can, if you have any 2 points, alright, with any coordinates x1, y1 and x2, y2, you can use this formula to find the midpoint of the line joining those 2 points. Next, we look at the idea of a gradient. So suppose we have a straight line. Now let's think about 2 points on the straight line. Let's say that point is at 1, 2. That point has coordinates for 3. Now the idea of a gradient is a number to tell us how steep this slope is. So it's a number that will be smaller for a gentler slope, like that, and bigger for a steeper slope if the line goes like that. And the way it is defined is to it's like that. If I just take any 2 points and then I draw a vertical line down from one point and a horizontal line from the other point to form a right-angled triangle, then the gradient is defined as the vertical side divided by the horizontal side. So let me call this A and B. So it's equal to A over B. So that's the mathematical formula, but what does it mean? If I'm dividing the vertical distance or the height by the horizontal distance, the answer that I'll get will tell me, if you imagine yourself walking up this slope, right? Let's say this is a hill slope. If you are walking up this slope, then this ratio will tell me for every horizontal, say every time you move horizontally by 1 meter, this ratio will tell you how many meters you will go up. So in other words, this ratio is the increase in your height for every meter that you move horizontally as you walk up the slope. And that makes sense, right? If for every meter that I move horizontally, I go up by a bigger amount, then I would have a bigger gradient for the answer. And in this example, where I have those values for the coordinates of the 2 points, let's calculate the gradient. Now, I'll use the symbol m to represent the gradient. So in this example, m would be a over b, and a is 3 minus 2. b would be 4 minus 1. Okay. And the answer is 1 over 3. So now I have a number for the gradient. Now, there is an important thing about gradient that we must know. Coming back to this triangle, you might have noticed that it's just one of the many possible triangles I could draw. For example, I could draw, say, this triangle. What if I draw a bigger triangle? Then will I still get the same answer if I take the vertical distance and divide that by the horizontal distance? Okay, let's check. Now in this simple example, we can get we can tell what the horizontal distance and vertical distance might be. So let's say, right, I know that this distance here is 3, right? From 1 to 4 is 3 units. Let me say that that point is what I get if I move another 3 units from 4 to 7. Okay. And the y-axis would be 4. Okay, because since those two are similar triangles, we would expect the ratio between the vertical sides and the ratio between the horizontal sides to be equal. So if I move by 3 units here and 3 units here, and then it must be 1 unit here and 1 unit there, so that the two ratios are the same. Okay, so that's what we would understand from similar triangles. And from this idea alone, we can already tell that the ratio A over B, which is the ratio between these two sides, must be the same between this triangle and the bigger triangle. Okay, but let's do the calculation anyway. If I look at the bigger triangle, I would find for the vertical distance, I would find 4 minus 2. For the horizontal distance, 7 minus 1. 4 minus 2 is 2, 7 minus 1 is 6, and 2 over 6 is the same as 1/3. So they are equal even when I take a bigger triangle. And we can now understand why. It's because if you take a bigger triangle, that bigger triangle is a similar triangle to the smaller triangle, in the sense that the corresponding angles are equal. And because of this, the corresponding sides would also have the same ratio. So if I divide the vertical side by horizontal side for the smaller triangle, I must get the same answer as for the bigger triangle. Okay. Now, and this feature, alright, this feature that no matter what triangle I choose, whether it's big or small, and no matter where I choose it, whether I choose it here or there, I will get the same answer when I calculate the gradient using this formula, using this vertical divided by horizontal distance. So that's why this idea of gradient is useful, alright, because you can use it anywhere you are along the line, and it gives you the same meaning. Okay, and like before, let's make a formula for this gradient. So to make a formula, instead of using numbers, we replace it by symbols, so that I can use it for other values. So x1 is this number, I'll let x2 be that number. I'll call this x1, I'll call that y1 and y2. So I'm looking at the big triangle. Okay. I'll write it down here. M is the gradient. Then the vertical side would be y2 minus y1. The horizontal side would be x2 minus x1. And that's the formula. We can use it if we know the coordinates of any 2 points on the line. Okay, next, let's have a look at parallel lines. And suppose on this xy graph, I have 2 lines. Okay, and suppose they are parallel. Now, if they are parallel, the gradients must be the same. Right? Simply because they have the same slope. Just by looking at it, you can tell. Let me draw that triangle just to have a look. So let's say I make 2 points on the line and I draw a right angle triangle with vertical and horizontal side. Okay. And let's say the horizontal side here is B and the vertical side there is A. Okay. Now on this line, let me just pick any point and I'll draw a horizontal side with length B. And then I'll draw a vertical side and ask, what is the vertical side? Is it the same as A? Well, it looks the same, and we'll show that it's the same. But just to be sure, let's think about why it is the same. Alright, in maths we can't just say things because it looks the same. We have to prove it. Okay. If you look at those two triangles, one side is the same. Now that angle is the same. Alright, because the two lines here are parallel and the two lines here are parallel. Okay, so this is the property of corresponding angles. The two angles are the same. And that's a right angle, so that's a right angle. So now we have two triangles in which two sides are the one side is equal to one side, two angles is equal to the other two angles. Okay, and from this, from the fact that these things are equal, right? The side and the two angles are equal. We can actually say that the two triangles are congruent, that they are exactly the same. So therefore, this side must also be equal to A. Right? So now that we are sure that this side is also equal to A, we can then see that the gradient of this line must be the same as the gradient of this line, because gradient is defined as A over B, the vertical over the horizontal side. So that's also A over B. So therefore, for parallel lines, the gradients are always equal. Let's now take a look at perpendicular lines. The line there, and a whole line L1, another line here which I'll call L2, and they're perpendicular. Now what I want to do here is to think about the gradient for each line and see if there is some connection between the two gradients. Right? Like just now I looked at two parallel lines and there was obviously a connection. They're equal, right? So what about this? Is there some kind of connection too? Now let me start from the point of intersection and draw that triangle, the horizontal side and a vertical side. Okay, so that's side A and B, horizontal, vertical. And I know that we can find the gradient. Okay, we know that we can find the gradient by doing A over B. So let me write this down. This gradient here for line 1, let it be m1 and it is equal to A over B. Now what about line 2? Okay. If you look at this triangle here, look at that triangle. Now imagine that that triangle is a real object. Okay, it could be a block of wood or a piece of paper. Suppose that I can grip onto this triangle, okay, and rotate it around. Right? If I take this triangle and I rotate it until it comes up to here. Now, suppose that I rotate it until this side becomes vertical. So that's the side B. Now, if this side becomes vertical, what about that side? Where does that side go to? Now, I'm rotating it by 90 degrees, right? So that the horizontal line becomes vertical. Now, but we already know that those two lines are perpendicular, that those two lines are also 90 degrees apart. So that means that when this side gets rotated by 90 degrees, this side must fall on that side. Okay? So that point, for example, would come to here. And then the remaining side would just simply fit in like that. Okay, so the horizontal side becomes the vertical side becomes horizontal side. So it just happened. Now, can we now use this triangle to find the gradients of L2? Now let's M2 be the gradients of L2. Okay, it's a little bit tricky here because this orientation is a bit different from what we are used to. Right? We are used to having a line going that way and a right-angled triangle below it. But now we have the line going the other way. So let me flip this triangle over. Let me draw it down here instead. Alright, it's just kind of symmetrical. I'll just turn it around. And that would be my B and that would be my A. Okay, so I can have an identical triangle below the line. Okay. So now we can have we can look at the vertical and horizontal side and write down the gradient. So it should be B divided by A. Okay. But there is one thing we have to do. in this case, where the line goes this way, okay, if the side B is going towards the positive x direction, whereas in that other line, the horizontal side is going towards the negative direction. So we should use a negative value for the horizontal side. So I should add, but A itself comes from there, and that was positive. So we need to turn this into a negative number. We have to add a minus sign to A. So this means that if the line slopes the other way, it is given a negative gradient. Right. So now we have the answer for the gradient of L2. Now if we look at those two expressions, M1 is A over 2, M2 is B over A, there are obviously similarities, and the way it is usually written is this. You know that A over B is just the inverse of B over A, right? You take A over B, turn it upside down, you get B over A. So B over A is just 1 over M1. So M2 is minus of 1 over M1, and I can bring M1 over to the other side, and I get M1, M2 equal to minus 1. So that's the connection between M1 and M2. The product is equal to minus 1. Now, if there is also another way to arrive at this. If you forget about that for now, just look at those two. If I simply multiply M1 and M2 to get this, then when you multiply A over B by B over A, the A on top and the A at the bottom cancels. Likewise, the B and the B cancels. And we'll also get 1 with the minus sign. So we have just derived a formula that relates the gradients of two perpendicular lines. So let's look at some examples now. Suppose I have 3 points, A, B, and C. The question is, show that those 3 points are collinear. So collinear means that they all lie on the same straight line. That's the question. The way to do that is to think about a line joining the points, joining A and B and joining B and C, and say that if this is a single straight line, then the gradient of AB must be the same as the gradient of BC. So all we need then is to find the gradient of AB using those two coordinates, find the gradient of BC using those two sets of coordinates, and check that they are equal. And we can find the gradients using the formula for the gradients. So let's try. Gradient of AB So recall the formula for the gradient. We must take y2 minus y1. Alright, if I call this x1 y1 and x2 y2, then I must do y2 minus y1, which is half, divided by x2 minus x1. Okay, which is minus 1/3. And the answer is minus 3/2. That's the gradient of AB. And gradient of BC, likewise, I believe that there should be a minus sign there. Okay, let's try. y2 minus y1, that gives us 4.5. x2 minus x1, that gives us minus 3. Okay, so 4.5 is 9/2. 9 divided by 3 is 3. So we end up with minus 3/2 as well. So those two are equal. Therefore, AB, BC have the same gradients. Therefore, ABC all lie on the same straight line. And therefore, they are collinear. Right, in this example, we have a triangle and we are given the coordinates of the three corners of the triangle. And from that corner, draw a perpendicular to the opposite side. And the question is, find the point where this line, this perpendicular, intersects the y-axis. I'll call that C. So find the y value of that point C. Okay, so this is a bit more tricky than the last example, and we need to think of some idea about what we can try using what we have learned so far. There is this thing that this line is perpendicular to this line. Okay, so you have two perpendicular lines here, and that reminds us of the property of perpendicular lines. Let's write that down. For perpendicular lines, we have the property that the gradients multiply to give -1. I'm using that symbol to mean perpendicular. Okay, so we might have to make use of that for those two lines. Okay, and if I make use of those two lines, what can I find? Right, since that property is about, that formula is about gradients, let's think about the gradients. For this line, we can find the gradient because we know the coordinates of those 2 points. Now for that line, we don't know the gradient because we only know 1 point. But then this formula will help us to find this gradient. Okay. So supposing that we have found the gradient of that line, how does that help? Well, we know the gradient of, we know the coordinates of 1 point, and we know that in order to find gradient you need the coordinates of 2 points on the line. In this case we only know 1 point. We don't know what that point is. That point is what we need to find, but we do know the gradient. We already know the gradient this time. So this means that we had the formula relating 2 points to a gradient. So perhaps we could use that formula to solve for that point. Write that down. Gradient formula is that. Okay, so for this line, supposing that I've found the gradient, then I would know M, I would know the points of, I would know 1 point, That might be, say, x2, y2. And I want to find another point, which could be the x1, y1. But then there are two unknowns, x1 and y1. I can't get two answers from one equation. But then, for that particular point, we know, since it's on the y-axis, we know that the x must be 0. So that means that perhaps x1 is 0. And I'll just be left with finding y1. Okay, so after thinking about these ideas, okay, making the connections between what we see in the question and what we have learned, we have a plan. So the plan is, let's start by finding the gradient of that perpendicular, and then we shall try to find C. Okay, so let's do it. To find that gradient using this formula, we must first find this gradient. Okay. So I'll just put a m, say m1 next to that, and I'll call that gradient m2. Okay, so let's find m1. m1, the gradient of this, we would use that formula. Okay, so let's say that's okay, right, let's say that's 0.1 and 0.2. So I would do y2 minus y1. So minus 2 minus 3, that's minus 5. x2 minus x1. So 1 minus minus 2, which is 1 plus 2, that's 3. So therefore, using that formula, m2 must be minus of 1 over m1. So minus of the inverse of that, so we flip that upside down and get 3 over 5. And the minus and minus cancel, so now it's a plus. So now I have the gradient of this line. Okay. And the next thing to do is to try to find the C using that formula. Okay, so m there is 3 over 2, right? M2 is 3 over 2. So let me use that formula, write down 3 over 5. I write down 3 over 5 for the m, and that's equal to y, right, that formula, right? So let me call this point y1, y2, this is point 1 and that's point 2. Okay, point 1 and point 2. So that's the y value of that point, right? The value along the y-axis. The coordinate of this point should be x equals to 0 and y equals to c. Okay, so that's the full coordinate for that point. So I'm going to take that as point 2 and point 1. Okay, so using that formula, I have y2 minus y1, which is 4 minus c, divided by x2 minus x1, which is 2 minus 0. And now I have an equation that I can solve. So let's do it. Cross multiply. 2 times 3, 6. 5 times this lot. So I get 5 times 4, 20. 5 times c by c. Okay, so let's continue down here. 5c bring over to the left. 6 bring over here to give 14. So therefore c is equal to 14 over 5. So now we have the answer. We'll stop here.